We'll now finish the three-dimensional point groups by just looking at one combination, a horizontal plane with the 432, and also there are no other combinations 4-bar, but we'll just show you, why that is, just for the fun of it. So 432, just to remind you again, that is another cubic system, but we use the cube to identify so this would be the 4, if you recall. And then this might be the 3 coming on the diagonal here, the 1, 1, 1 direction. And then this would be a 2. So really quite common to those of us who work with cubic material systems. And looking at the stereographic projection for that, again, if we look down here, you'll see that obviously there's a fourfold axis, and there's fourfold axes coming out of each one of those directions. And in the corners we have our three folds. Difference here is that as we look between their three folds, you end up with a twofold, right? So everywhere, kind of like that. Oh, I drew this wrong, by the way. This is a twofold. This is another fourfold coming out of here. And as you pass from one fourfold to another, you pass through one of these edges. And so you see a twofold coming out. And there you have it. That's the 4, 3, 2. So now, usual thing, put in a horizontal, and just like the explanation I did for the 2, 3, is that what happens here is, even though it's very highly symmetric, it's still possible to have, and you'll see it if you go look on the chart we're going to show you at the end of this lecture, which summarizes everything. If you look, you'll see like there's ways to have things on this part of the sphere that are not on the backside. So all this does is reflect everything else around, right? But the way you're going to see this is that obviously this makes mirror planes appear here. They make them appear here. They appear here, and we have twofold axes perpendicular to mirror planes. So this has an inversion center. There's an inversion center inside. That inversion center means that what happens is these threefold axes end up having it because they're passing through there, and so that the reason we point that out is that the other ones you're going to end up with the fourfold axis is clearly going to be a 4m, right? And the twofold axis is going to be a 2m. Right, we've seen that many times as implied inversion in there, so you don't indicate that there's an inversion center. But remember with the 3, you do imply that because the 3 is unique with if the threefold axis has an inversion in it, then you end up having a 3 bar. So this is 4 over m, 3 bar, 2 over m, and that's the only combination that matters. Don't want to spend too much time on so just remind you that what 4 bar is. the symbol is a rotor inversion, and there's the motif. Now I think you can see pretty clearly that if you either do one bar or horizontal, what happens is you take the red one, and if I do a mirror plane on it, I end up reflecting it to the back side. And so what happens is for all of these, it ends up being the same. And you can see that that comes from inversion as well, because if I invert, right, then this would come over and create that, this would come over, create that, and vice versa. And so you end up with this no matter what you do. And so for two extenders, all we end up with is 4 over m, which we've already done, of course. If we do a vertical mirror plane, then what happens is this one gets reflected on the back side. Don't forget, so this guy gets sent here, that guy gets sent here. This guy gets sent here, this guy gets sent here. We have seen this before. And if you look at that motif pattern without putting in the rest of the symmetry elements, you should see that this is 4 bar 2m. And we are finished with this column now. We have now done the one that we can do here, and then we already had this one we added to the end of that, but then we played around with adding these things and they don't produce anything normal. And so that is it. We are now finished with a 32 the 32 three-dimensional crystallographic point groups.